Milan. How's everyone doing today? How is everyone? ¿Cómo está? Yeah, great. My name is Yunong. I'm super excited to be here to talk to you all about our Paved PaaS to microservices here at Netflix. Anyone heard of Netflix? Nobody? Woo! Yeah. So for those of you who haven't, a little bit about Netflix. We have 110 million customers in over 190 countries, and some absolutely huge numbers, right? 125 million hours that's streamed every day. And we had some really phenomenal subscriber growth over the last few years. In 2015, we launched in Italia, so thank you, Italy. And in 2016, we went worldwide. And today, the international audience is more than 50% of our members. So we really love everyone outside of the U.S. as well as everywhere else. And what we're really known for, and the key for us to grow our business and our subscribers, and we're making our customers, you guys happy, is to provide really quality original content. So has anyone seen some of these shows? I see a few. That's great. I love BoJack Horseman. It's a really great tragic comedy. It's fantastic. But we've also, released our first Italian original series a month ago. Anyone seen this one? A few? That's great. And so, in addition to the really great originals content that we're trying to provide for customers, the other thing that we want to do is to create a bespoke experience for our customers on every single device that's out there, right? So whether that's a TV or a smartphone on your TV or on the browser, we want to make sure that that experience is great because, the more that you can engage with us, the better our business is. So the key question here is, how does it all work, right? What is, if we peel back the curtains behind Netflix, how does the service work? Well, talk is about microservices, and most of you have probably heard of the fact that we have a microservices-driven architecture, right? And this is a picture of one of our tools that we use, and this shows, all of the microservices that's running a region, right, in an AWS region. And there's probably, 500-600 microservices here, and these provide data for every aspect of the Netflix experience. So that's whether that's loading the titles that's required to render the UI, or recommendations, or sign up, or anything that you can think of when you interact with Netflix, it's provided by one or many of these services that's shown here, right? And so how do we reconcile the two? We've got lots of great devices out in the field, and we've got all the microservices in the back end that provide the data, right? How do they talk to each other? Well, if we just do the naive thing and have them talk one-on-one, right, you end up with this, right? One of my favorite Italian dishes, spaghetti carbonara, but it's really, really difficult to debug in production. It's very hard to have high velocity because every time you need to make a change, you either have to change the services or the clients, and they're just all intertwined together. So it's really difficult. Delicious, by the way. But and so we created something that's kind of the integration point between the clients, right, and the microservice in the back end, which we call the Netflix Edge API. So this is api.netflix.com, and it consolidates all of those back-end microservices into one consistent API. And that lets you do things like discovery, to discover great content, to sign up, to play back, and many other things. And it lets the clients and the microservices all talk through this one integration point, right? And it's great. It separates and decouples the two layers together. And that's the team I work on. But what are some of the requirements for this Edge API, right? If we think through what the requirements are, well, to give you some examples, one is sort of this rapid innovation A/B tests, right? So we do about 1,000 or thousands of A/B tests every single year, and each A/B test has 10 or 20 or 30 different variants. So that's a lot of change that's always happening all the time, right? And they have to go to production, and so we naturally push code quite a bit, right? Every day, every other day. Of course, not on Fridays, but every other day of the week, we push code. And also, the services that we write, they have to be bespoke, right? We're in the fashion capital of the world, right? And just like how everyone is different and needs their own set of fashion and style, every single service and every single client that relies on those services needs a specific set of APIs for that specific client, right? Your iOS client on mobile is going to be very, very different than the TV UI, and it requires different sets of data and services. And because everyone's unique, in order to sort of make it easy for these client teams to integrate against the Edge API, they need the ability to create standalone services that mutate and change and refactor that data that they get from the Edge API, depending on what A/B test they're running, what kind of test they have going on, what client that is. And so if you think about the scale of these services in front of the Edge API, we're talking about thousands of routes, and they're pushing multiple times a week, right? And you have to imagine that, we have two goals here, right? One, which is velocity, because we want to enable the high rate of change. And if we have a high rate of change, it means we can innovate and test and make the service really great for everyone out here. But there's also reliability, right? If you change so fast that the service is unavailable all the time, of course, customers are going to have a poor experience. And so this is a good time to introduce platform as a service, right? And the definition here is that it allows you customers to develop and run applications without the complexity of having to build and maintain the infrastructure in the platform, right? And we think by using platform as a service, which we'll get into in the rest of this talk, it really lets us be able to blend both velocity and reliability together. The one last thing that I want to mention before we get deeper is knowing your customer, right? We really have two different sets of customers who run services on Netflix. We've got the client developers who have to run their bespoke services that create data for themselves. And we have the back-end server teams that run all those other microservices. And there's two different types of engineers who work on these teams, right? One of them is really great at front-end responsive design, making really killer UIs. And that's the people that we're trying to target. And they don't have that experience of running really robust services. It's really hard, as many of you know. And so how can we simplify that sort of path for them, right? And so our platform as a service to achieving both of those things, velocity and reliability, really comes down to three things which we'll walk through today. Standardized components, a pre-assembled platform, and automation and tooling. So let's talk about the first one, right? Standardized components. Anyone here use microservices in their day-to-day? Can I get a show of hands? There's quite a few of you. So you know that when you build a microservice, there's quite a lot of components that go inside, right? Not all of them are needed to sort of run a service, but to run one reliably, to be able to operate them, to make sure that they're always available, you need all of these things, right? Whenever they crash, you kind of need things like logging and metrics and integration and discovery and all of these things to be able to run reliably a microservice. And luckily at Netflix, we have a great core set of libraries that's maintained, and it's open source, so you all should check it out, that lets us easily build microservices together, right? So why are standards so important? Here's an anecdote from real life. Sci-tech confusion leads to Mars failure, right? On the BBC. And if you zoom in, there's this probe that crashed on the surface of Mars. And the reason that happened was one team used imperial units, and another team used metric. So very expensive billion-dollar probe. They spend years sending it to Mars and crashes on the surface, right? It's very silly. It's the same thing when you're building a service, right? If you take RPC as an example, there's lots of really, really great RPC frameworks out there. I'm sure you've all used some of these, right? And arguably, one is not better than the other. There's lots of them. And so suppose I've got a set of microservices that are talking to each other, and they all speak different RPC protocols with each other, right? And that's all fine sort of in a happy case. Everything's working correctly. Everyone's happy and streaming Netflix. But what happens when there's failure? Well, one, our customers get really angry on Twitter, right? But also, our biggest goal for us and our operations teams is to reduce these two things, right? Mean time to detection, the fastest time, how do you know when you have a problem in the system? And mean time to repair, how long does it take for you to fix it? And as engineers and developers here know, this gets asked all the time when your services are down from your managers, right? Is it fixed? Is it fixed? And so you imagine hey, I've got lots of different kinds of RPC going on in my system. How do I go and debug that, right? Do I need a new tool for each RPC mechanism? If I'm the site reliability engineering team and they go in and try to fix the system, now do they have to understand every single RPC mechanism? Do they have to understand all the tools that's associated with that? That's really, really difficult, right? But if we're able to standardize and just use one RPC mechanism, even if it's less efficient than something else, standardization is really key because now you've unlocked a lot of the benefits. And if you can blast this out to sort of all the components that you're using inside of a service, to discovery, to registration, here are some of the benefits that you can unlock, right? Consistency, right? Every single service is using exactly the same set of components. It makes it much easier to debug. You have a lot more leverage now, too, as a company, right? Because you could have one team that maintains all of these components, and now the entire company can use them. Interoperability is another great one where all these services can just easily talk to each other without any special setup. And also, because you have this team or a centralized team that's managing all these platform components and they're not being hand-rolled by every team, you get much better quality software. And also, support is huge too, right? Because now you can consolidate all the knowledge in one area, and you may have like lots of knowledge for all these specific standardized components that everyone can easily look up. So again, it helps to increase the velocity and the reliability. But what happens if you want to be different, right? If you want to be a different service because you may have some specific use cases. Well, at Netflix, we have this culture of freedom and responsibility, which really means that you have the freedom to really do whatever you want, but you should be responsible. So, you can go off-road, choose a different framework if you want, and that may unlock a lot of innovation for you, right? So lots of new technologies that are coming in. You don't want to prevent your engineers and developers from using them, but they need to then think about like, okay, if I bring in, say, a new runtime like Node.js or Go or something, how do I reintegrate that back into the core system so that everyone can get the benefits? And from the responsibility side, don't just use new things because they're new and shiny. Use them because there's a good fit for them. Don't make decisions in a vacuum, right? Talk to your platform teams to make sure that they understand what you're doing so they can better support you, and your reliability teams will understand the new technologies. And know that whenever you introduce new technologies, you're increasing the technical burden for the entire organization, right? So for your team, it may be really, really great to use Rust or some other runtime, but know that now every single operations team and support team has to now figure out how to use Rust as well. So again, it's kind of that sort of pendulum of freedom and responsibility. So the next section I want to talk about is having a pre-assembled platform, right? You're ready to go, you've launched some new feature, and now you want to assemble a new microservice, right? Well, here are all the different parts to it, right? And you need to put that together in a reliable way to run a microservice. It's a bit like this, right? You go to IKEA, you see that in the showroom there's a really nice chair, like, I want that chair, or your wife says, you want that chair, and you bring it home, and you're trying to avoid this, right? And so how do we do that, right? If we take that analogy and bring it over to the microservices world, what are the instructions, right, for getting out of the blocks with a service? Well, I have to read some docs probably somewhere in the company, copy-paste a bunch of code that maybe exists somewhere, hopefully, figure out which versions of all the components to use, make sure I've got initialization right, make sure I'm configuring it correctly, hopefully I'm not missing anything, right? And this can take you days or weeks to just even do that, right? And so trying to launch a new feature, I spent 2-3 weeks trying to just even stand up my microservice. I don't have velocity or reliability. And by the way, I haven't actually written a single line of business logic, right? So this is terrible. This is not acceptable. We can't get the velocity that we want to make our customers happy. So what can we do here, right? And this is where a pre-assembled platform comes in because, as a platform team, you can provide a platform that has all of those components that we just talked about that are standardized already baked in. And so that as a customer who wants to just run a service, all they have to do is just drop in their business logic. And that's all they need, right? And now when they start up, they don't have to try to put anything together, and all they have to put in is just their business logic. So what do you get out of the box, kind of with our platform that's pre-assembled? Well, for one thing, you get component management, right? So we're talking about like, hey, here are all the steps that you need to do to like build a microservice, right? I left out one big component, which is metrics, insight, and alerts, and logging, and all of that, right? So your service works fine really well until the first time that it doesn't, and then if you forgot alerts or metrics or logs, you have no way of knowing when the service is misbehaving, and even if you know, you can't test it, you can't check what's actually broken, and you can't debug it very easily. And so by having a pre-assembled platform, you can ensure that all of these components are built in so that people don't forget things, right? What about insights, right? Even if you built in, alerts, logs, metrics, right? If everyone just does that themselves and hand rolls it, they're all going to have different types of alerts, right? Different types of metrics, different types of logs. And remember that our goal is to reduce, mean time to detection and mean time to remediation when Netflix is down, we want to make sure we get it back up as fast as possible. Imagine now you're the site reliability engineering team, and something's broken with Netflix, and you have to go through all these services. If everyone's emitting different sets of metrics and logs, again, it becomes very difficult to debug, right? So by pre-assembling and pre-packaging a platform, right, we can ensure that we emit a baseline of metrics that's the same for everyone, that's consistent, right? So, emitting a metric for every request that you get, a log, emitting latencies, right? All those things can make sure that, we're actually reducing mean time to detection, MTTR, which is really, really important for running a service, right? What about configuration and initialization, right? This is something that folks don't usually think about, but like, I have all these components, right? How do I start them correctly? Do I need to start my configuration client first and my metrics client? When do I register that service with discovery so other services can route to me? Order matters, configuration matters, and if you think about it, it's almost like trying to figure out how do I take off, how does an airline take off, right? And how do they do this? Well, they have this big checklist, and you go through every single step to make sure that it's safe, because you have people on board. With a service, it's kind of the same thing, right? You want to make sure every time you start the service, it starts up safely. And so by having a pre-configured platform where you're just writing business logic, and that logic of starting and configuring the service is already baked in, then you know that every time you run and start the service, right, that it starts and configures itself correctly, and you're sort of reducing the chance of error, right? Additionally, having a pre-baked platform means that the platform team is managing all the versions of all the components inside the platform. So you probably, for those of you who run services, you know that it's often pretty dangerous and often difficult to update versions of all the dependencies that you have, right? You don't know if you update a dependency, whether that's going to break something, whether there'll be performance regressions. And so by having a platform team handle all of that for you for the platform, they can make sure to test that there are no performance regressions, that everything's compatible, right? And save that sort of all that hard work so that the service teams don't have to worry about that. Again, giving them better velocity and reliability. And so here are some important questions around having a pre-assembled platform that I want you guys to think about. What's actually in and out of the platform, right? Is it, I've got a base platform that lets me run a service, but what happens if I have a front-end app, right, that needs to render UIs? Do I put React in there? And then if I do that, does everyone else get React? And if I'm running a mid-tier service that doesn't have to render UI, they now have extra code and dependencies to manage, right? If I'm trying to do RPC with Falcor, which is the Netflix compositional REST protocol, does that need to be in there? Does everyone else need it? Same thing with caching, right? And obviously, this blows out to lots of other different dependencies, but what's in and out of the base platform? Well, the solution for us is use different layers, right, and have different flavors. So we have a base platform, and that gives you sort of the bare minimum that you need to be able to run a microservice. But if you're doing data access, then we'll bake in stuff like Falcor or caching to really, again, fully manage that for you. If you're doing, rendering a UI or a browser-based app, we can bake in the sort of the UI components for you. Same thing for backend, and this can, sort of go on and on. But having different flavors and layers that then we manage that build on top of each other, it's very important as well. How do you ensure that the platform itself is correct? And this isn't the service itself, but actually the platform. So, we're pulling in a bunch of components that's owned by other teams. How do we ensure that's correct? Well, obviously you test, but what are the tests? What are the tests comprised of, right? So it's really important for you or for us as the platform team to make sure we have all of these different tests. So unit tests, integration tests, functional tests. It's really important to test in the cloud, to test on every single PR. And lastly, for us to use the platform ourselves, right? And so one of the things that we're trying to do when we're updating the platform for all of these services is we'll often canary the platform on our customers' production services. A very thin sliver of the production traffic goes to the new platform for a set of different services. And that gives us a good litmus test to see whether the new platform works for everyone, right? And if it does, then we'll do a slow deployment. But again, it's all about using the platform yourself and being very sort of thinking very hard about testing to make sure you don't break anyone, right? But how about the component themselves? We have our customers on the left here who are using the platform, and we're really the gatekeepers for them to all of those components inside of the platform, right? But for the platform team, we don't actually provide most of these components. We have other teams to provide the discovery client or the metrics client, and et cetera. So how do we make sure that these components are correct since we don't provide them? Well, one thing we do is we lock down all the versions. So we explicitly will update them only when we've tested them, when we don't just randomly pull them in. And we make sure to test every single component. So we write a lot of tests inside the platform that make sure that these components have the functionality that we expect. And every single update of these components from our partner teams that are providing them, they need to provide a PR, and that goes through our continuous integration and deployment pipelines to make sure that it hasn't broken anything. So the other question that you guys might naturally have is, hey, how locked down is the platform, right? If you only let me write business logic, what if I have a use case where I may need to do something else? I may have to do something before the application starts. And that's where we're really talking about the trade-off here between sort of flexibility versus reliability, consistency, and support, right? Because the more flexible you are, obviously the more use cases you unlock. But then if people are changing stuff before the application starts, maybe they've changed it so much that the metrics no longer work, or it doesn't start the way that we expect, and now we may no longer have a consistent fleet, right? And it makes it hard to support all of these services. So for us, our sort of recommendation to all of our customers is try to stay on the paved path, right? The more that you don't change anything and just write your business logic, the easier it is for everyone to be able to operate these services. But it doesn't mean that you lock down the platform so people can't use it, because again, we have that culture at Netflix of freedom and responsibility. So we do have all these APIs available for you to use the platform. So you can override the configuration. There's startup and shutdown hooks with a platform for you to start additional components if you want. You get access to third-party libraries. You can swap, disable, or configure any of these components. And you even get access to these raw component access, right? But again, the thing is, it's not to say you can't do any of these things. It's more, think about having a conversation with those teams who want to do these things. A lot of times, maybe they're already, what they want to do can already be solved by the platform. Maybe they just, they don't know how to use it, or there's some sort of a misalignment. And platform versioning, right? That's really important as well, because if you mess up versioning and you push a new version of the platform, it may completely break all the APIs and therefore break all of your customers. So we decided to use semantic versioning, and that lets our customers pin to specific versions of the platform. So they can pin to an actual version, they can float on a major version, on a minor version, or they can float on a patch version. That ensures that they have great platform compatibility. And as the platform team, we use conventional changelog, which is a really great way. I think everyone should use these for their projects, whether it's a platform or not. But it gives you a really easy way to manage changes into the platform and automatically updates all the versions for you once you do. So the last item I want to talk about was around automation and tooling, right? So you want to ship a feature, and it's usually in Jira somewhere, and you want that to go out into production, right? New original show comes on, and you want that to be the first thing that everyone sees when they log in. I have to ship a feature. So what are some of the steps that I have to do in order to make that happen, right? There's usually some amount of development work. Then I have to test it. Then I have to deploy that to the cloud somewhere, and then I have to operate the service. So how can we kind of speed up and make these things faster, but at the same time make them safer for our customers? So let's talk about development, right? We want development to look like this, right? And want to be super fast, right? But as all of you know, if you start a new company, they give you a laptop, or you're trying to spin up a new project that you haven't worked on before, a lot of the times the first few kind of days or weeks you're spending time installing all the tools, right? And now everything gets installed correctly, right? Maybe you have a different version of Docker, or a different version of Git, or Python, or Java, or whatever it is, and your company runs a customized version of the runtime, because usually they've customized a lot of these things to make it work for the infrastructure. And so if you're just going off like some sheet of instructions, you're liable to get it wrong, right? So how can we make this better for developers? Well, we've created a CLI for a common dev experience. And that includes a bunch of things, but one, it entirely bootstraps your development environment for you. And it pulls in all the dependencies, make sure that the versions are correct. So things like Git and Docker and Node or NPM or Java or whatever it is, and make sure that all those things are in the right places, they have the right versions. And it's really important, too, that the tool itself will update not only itself, but all these dependencies for you. So you imagine, you have a problem with your environment, something's not working, because you have now a consistent tool and a consistent environment, you can actually type, like, the tool is called Newt, but you can type Newt help or report error, and that sends a roll-up of your entire environment to the engineering tools team to make it much easier for them to debug for you, right? The second of all, it integrates against all the tools and services in Netflix. You imagine, like, pushing and deploying a service requires a bunch of coordination between a lot of components, right? Something that delivers that application to the cloud. You have to bake that your source code into an image that you can deploy to the cloud. You may have to go initiate a pull request and go through all the build tooling. This tool integrates all that for you as well, so that you really just have a one command that you can write that will let you deploy whatever you have currently that you've got locally to the cloud somewhere. So that really saves a lot of time for our engineers. And lastly, having this tool means that now you can run your source and your code both locally and in the cloud. So what do I mean by that, right? Generally speaking, typically, if you're in the cloud and you're a big shop, it's pretty difficult to replicate a production environment locally, right? You have a lot of components in play, but because we have this tooling and we have a way to consistently manage the environment, and we're using Docker, you can actually just the tool will bring in the Docker container for you with a Docker image of the build that you're looking for, right? Or a development environment. And you get stuff like live reload, which the tool manages. So you're like developing locally, the code automatically gets pushed into the container and manage all of that for you. And so now you can attach a debugger while the container is running locally. You can see all the logs. You can hit the API endpoints all locally in your computer. And this is really, really fast. Like, I'm talking seconds to be able to go from a code change to seeing it bounce in the container to be able to being able to test it. And also, you can drop in production containers that may have problems locally and debug them there to really make it easy for you to figure out what's gone wrong with your service. So what about testing your service itself, right? Generally speaking, you want it to find the tests not in production, but while you're doing testing. So how do we do that? Remember that we have this pre-assembled platform, right? And so how do we make sure that we're catching our bugs? And furthermore, the thing is with a microservice, you're generally speaking, you only want to test sort of as a service developer the code that you've written, right? And you're usually integrating against a bunch of other services out in the cloud. And so what does that mean? That means all these components that's in the service if you're testing, has to hit a pre-production environment somewhere. And this is kind of problematic because, as everyone knows, when you're in pre-production, people don't really run their services reliably, right? Because it's pre-prod. Things are broken all the time. And so when pre-production is down, that means that, like, hey, all of your developers now can't test and can't develop. So how do we kind of solve this problem, right, of all these services hitting pre-prod? Providing first-class mocks as part of the platform, right? So we can take most of the components that exist in the platform and provide mocks for them because, again, the developers who are working on the microservice only care about their business logic. And so if we can mock out a bunch of these components so they're not making RPC calls and they're returning some data that they expect, it really simplifies their test experience and their development experience, right? And same thing for the platform testing API. Just like a runtime API, you need a testing API, right? A way for you to say, set data for a test onto the platform, and then run the test, exercise that logic, and then check the test. So that's something to think about as well. If you provide a platform, it's not just about providing the runtime API. You need a testing API. Like I said, you need to provide a mocks interface for all your components. And the other reason for providing mocks is it gets the platform team out of sort of the loop for providing mocks, right? If you have an interface and abstraction for mocks, now you can tell all of your component teams, hey, whenever you want to provide a component for the platform, please also provide a mock. And once you have this pattern going on, then it becomes quite easy and natural for all your component teams to provide mocks so that their customers can test against them. And ultimately, our goal here is to make sure that we're testing fully and have the best coverage and the best test cases that we have before we go to production. So lastly, deployment, right? You did all that work, and now you're ready to take it to production. Well, production is really hard. It's almost like going to war because as soon as your service goes down, you now have an availability problem, and your business is now hurt, and it's sort of bleeding money, right? And there's some experience differences between various folks in the company, right? You've got these veterans of sort of who've run services for years, who know exactly what to do, and you've got sort of folks on the front end who are building clients, but they also need to run services, and they have different sort of levels of experience, right? And so how do you prevent themselves from shooting themselves in the foot, right? What are some things that we can do in terms of deployment to help them with that? Well, one, providing sort of a managed way to deploy managed services. So that means, hey, pre-configure your pipelines for deployment and rollback, right? And that way, if they have a pattern and a pre-configured pipeline, they don't have to invent that from scratch again, right? And they're less likely to get it wrong, and we're more likely to be able to provide them with patterns and pipelines that do things correctly, right? Like I said before, having a single command that you can use that wraps all the machinery to let you deploy to any stack, whether it's test or staging or prod, less likely to get it wrong, right? Because again, anytime you introduce a human into the loop, we're liable to get it wrong because we make mistakes. Integration of all your deployments so they automatically get a canary analysis, which is a way to sort of test whether your service is working correctly before you go full prod, right? So being able to add that to your pipeline is really helpful. And if you've never deployed a service before or operated before, you may not even know about the concept of canary, and so just building that into the tooling would really help. And again, things like auto-scaling, right? Things that folks maybe won't think about, like how do you being able to pre-configure that so that as your service takes on more traffic, it automatically scales up. Again, we'll avoid outages. So operations is important too, right? I've deployed to production now. How do I operate the service? How do I get the view into my service to be able to operate it correctly? And at Netflix, we have a whole bunch of different tools. We have delivery engineering tools. We have metrics. We have alerts. We have logs. All these different subsystems that you use to operate your service. And for engineers who may not have that experience, it would be really helpful for them for us to consolidate all those tools in one place, right? And so we've done exactly that. We have a UI that you can go to for your service that consolidates, where your instances are, where the logs are. It gives you a look into like the versions and the platforms that it's running. One-click links to things like dashboards and alerts, right? Speaking of dashboards and alerts, we auto-generate those as well, right? So to be able to, to be able to create a service and have all the alerts be automatically generated, all the metrics be automatically generated for you is really great because that means that you're not missing any alerts and we're giving you kind of, we're constantly refining these things to make sure that you're getting the best alerts and dashboards that we can generate given the experience that we had operating these services in production. And also building things like automated analysis and tooling, right? To be able to run CPU profiling and generate flame graphs as visualizations to improve the performance of your application. To be able to take heap dumps and core dumps to do debugging analysis when your service goes wrong. And automating all of these tools really helps our engineers run their service. So today we talked about three things, right? And really our paths to velocity and reliability. We talked about, hey, standardize your components, right? Make it really, really easy and simple for your teams and your entire organization to operate your service by standardizing them. Having a pre-assembled platform so that folks are less likely to get things wrong when they're trying to stand up a service and when they're trying to operate it. And automating everything that you can, automation, tooling, and it doesn't just extend to the things I talked about, but really anywhere where you can automate the process, try to do that because it'll really help you operate a service reliably and at high velocity. So I'm happy to take questions. Thank you everyone for coming. Ask me anything you want. Follow me on Twitter if you have questions offline. Thank you very much.